Lovely one. In this video, I am going to teach you how to differentiate a given function. My name is Anthony Osemensa, popularly referred to as Sir Tony, the mathematics doctor from Aplus lesson. Let us get into this particular video. This question reads, find dy dx if y is equal to 4x cubed minus 3x squared plus 5 all divided by x squared. Solution. The function is given as y is equal to 4x cubed minus 3x squared plus 5 divided by x squared. Now, this function consists of a subtraction and addition in between the terms. So this can be differentiation of sum or difference. So let's get into finding the dy dx for this particular function. If you're asked to find dy dx of a particular function, so it means that you're going to differentiate y with respect to x. That is to say, you are supposed to find the derivative of this function. And finding the derivative of a function means that you are finding the slope or the gradient of the tangent line at a particular point of this function. So in conclusion, differentiation is finding the derivative, and finding the derivative is finding the slope, which is the gradient. And that is given in the form dy over dx. So dy over dx is like the small change formula, which we call the slope. So once I bring dy over dx and I bring my equal sign, I'm supposed to go through the rules of differentiation. Now, since this is a sum or different type of differentiation, that means I'll take the term one after the other and differentiate with respect to x. This is what I mean. So for example, let me take the first term, which is 4x cubed. I will simply use a method called the which means multiply and minus. What do I mean? I will check the coefficient of this term. So x cubed has a coefficient of 4. And then I'll check the power of the term. The power of the variable x is 3. So I'll multiply the power by the coefficient, the power of the variable by the coefficient of the term. So 3 will multiply 4 to give me 12. Next, I will minus 1 or subtract 1 from the power of the variable. That is to say, reduce the power by 1. So it will become x raised to the power 3 minus 1. And x raised to the power 3 minus 1 will give us x raised to the power 2, because 3 minus 1 is 2. So I'll end up getting 12x squared. So when you differentiate 4x cubed, you will get 12x squared. So let me just bring 12x squared. So that means that is the differentiation of 4x cubed. It is 12x squared. The next term is minus 3x squared. So minus 3x squared. It is very essential to bring the sign so that you know the final answer for that particular differentiation. So if you remember, we will multiply the power of the term by the coefficient of the term. So 2 times negative 3 will give us negative 6. Then we'll reduce the power by 1. That is to say, you subtract 1 from the power 2. So it becomes x raised to the power 2 minus 1. And then 2 minus 1 will give us 1. So we get negative 6x raised to the power 1. And the power of 1 for a particular number or variable means no power. So we are going to get minus 6x. So minus 6x will be the differentiation for minus 3x squared. So when you differentiate minus 3x squared, you are going to get minus 6x. So let's bring it minus 6x. We will now differentiate the final term, which is 5 divided by x squared. It is a positive number, so we don't actually consider the positive sign. So let's differentiate this fraction. Now, since this is a fraction, you have to rewrite this in a perfect way to be able to know how the power will be. Now, 5 divided by x squared is just like saying 5 multiplied by 1 over x squared. When you multiply 5 by 1 over x squared, you still get 5 over x squared. I have separated this into a form that I will allow this to convert as an indices property. So this is what I mean. Now, 1 divided by any number is that number raised to its negative power. So you see that I have 1 divided by x raised to the power 2. It is going to become x raised to the power negative 2. So I'm trying to say 1 over x squared is also written as x raised to the power negative 2. So with that, I am going to convert this expression into x raised to the power negative 2. So it will become 5 times x raised to the power negative 2. Then I'll get the final number as 5x raised to the power negative 2. So that means another way of writing 5 divided by x squared is 5 multiplied by x raised to the power negative 2. That is, this one and this particular one are the same. This one and this particular one are the same. Now let's differentiate 5x raised to the power negative 2. We will multiply the power, which is negative 2, by the 5. So negative 2 times 5 will give us negative 10. Then we will reduce the power of the x by 1. That is to say, we will subtract 1 from the power of the x, which is negative 2. So it will become negative 2 minus 1. So x raised to the power negative 2 minus 1. So when you simplify this, we are going to get minus 10. X raised to the power negative 2 minus 1 will give us negative 3. So when you differentiate 5 over x squared or 5x raised to the power negative 2, you are going to get negative 10x raised to the power negative 3. So let us now replace it. So we get minus 10x raised to the power negative 3. Remember, we had a positive sign before we differentiated and we ended up getting a negative sign. And that is how differentiation works. So you have to be very careful about the operational signs. Now, you can choose to leave your answer in this form, or you can choose to convert 10x raised to the power negative 3. That is to say, dy over dx can be equal to 12x squared minus 6x minus 10 divided by x raised to the power 3. Remember, the negative power means that it can become a division. So it can come to the denominator. And when the x raised to the power negative 3 comes to the denominator of the coefficient 10, it will become x raised to the power positive 3. That is another way of writing it. And this is the indices way of writing it. So in effect, the final answer for the differentiation will be dy dx is equal to 12x squared minus 6x minus 10 all over x cubed. And that is the final answer for this particular function when you differentiate it. Thank you very much, and God bless you.